We have taken a brief look at electron dot structures before, but it has been a long time. It was like back at the beginning of the year sometime, or maybe in October, so it's been a while. At any rate, just to remind you, they come from electron dot structures, and the electron dots represent what kind of electrons? Oh, I heard it somewhere. Yes, valence electrons. They represent the valence electrons. Okay, so group 1 has 1. Group 2 has 2. Group 3, 3. Or sorry, not group 3. Group 13 has 3. Group 14 has 4. And this is on page, let's see, what page are we on? 7. So 13 has 3, 14 has 4, 15, 5, 16, 6, 17, 7. And when we draw, don't get freaked out by this, when we draw valence structures for the noble gases, we show them as being full, not empty. Okay? So if you look at the Lewis structure for neon, it's got 2, 4, 6, 8. And where do we put all the electrons? We put them on the top, on the top. We put them on the bottom. We put them on the right and on the left. Should you ever have more than 2 electrons on a side? No. Should you ever pair up electrons before you have to? Say here, should you have paired electrons in carbon? No. Okay, the only exception to that is helium. Why is helium like this and not like this? Because it has a full valence shell. Yeah. Okay, and so it's not like that. So sulfur is group 16. Usually the easiest way to do it is just to put sulfur, and then if you're concerned about putting dots where you don't want dots, go 1 at the top and then go around 2, 3, 4, 5, 6. Then you will never pair up before you have to. Does that make sense? Okay, good stuff. There are no electron dot notations for the noble gases, or not the noble gases, the transition metals, so don't bother with them, okay? We have something called the octet rule. And what the octet rule says is that each atom likes to have a complete octet. How many electrons do you think a complete octet is? 8, okay? And that is when it bonds with other atoms. This is called the octet rule. Our exceptions are hydrogen and helium. Helium is already full. And hydrogen, what will it take to fill hydrogen? Only 2 electrons needed to fill hydrogen. So only 2 electrons needed to fill n equals 1. Mentioning again here that the noble gases, they already have 8 electrons, so they are hardly ever involved in bonding. Non-bonding electrons are called lone pairs. And have you been seeing lone pairs in your molecules this week? Yes? Okay, so if you haven't picked up on it, the ones that looked like this Okay, and they didn't have dots in them, but I could draw dots in them. That might actually be a good thing to do. The ones that looked like that were the lone pairs, or occasionally they kind of looked like this because I ran out of the nice ones that looked like that. So oxygen has 2 lone pairs. So these are not involved in bonding. These are non-bonding. How many bonds does that make it very likely that oxygen will form? Yeah, and O usually forms 2 bonds. There are exceptions, especially when you have ions, because if you have an ion, you'll actually have more or less electrons than you normally would. So we might have something that's become, if we had an extra one in there, maybe it'll only form 1 bond because we've got an extra electron pairing up there already. Chlorine. Normally, well, it's got 3 lone pairs when it's on its own. And so normally, how many bonds? 1 bond, usually just 1 bond. Okay, and that's for covalent. Magnesium does not covalent bond. What kind of bonding does magnesium do? Ionic bonding, so it's actually it will give away its 2 electrons to empty out its valence shell. So let's just play around with these 3 atoms for a moment. And I'm going to do it off on the side here. You might want to have some extra paper somewhere. This isn't going to be super important, but if you want some blank paper, feel free to go get some blank paper. So if I asked you to make an OCl2 molecule, what would that probably look like? You have an O and an O and a Cl. Oh, thank you. Yes, 2 Cls. Oopsie. A Cl and a Cl. See if you can put those together. Remember, when you turn them into bonding electrons, draw a line instead of dots, if you can. If you want to draw dots, that's fine for now. I can't keep up with it. Well, I'm trying to draw red on top so that they look different, but they keep going back to the black, so I'm not quite sure. Anyway, so give that a go. Have you guys finished? You got one finished? So where did you put the O? Did you put it on an end or in the middle? In the middle. It's going to have to be the one that goes in the middle because it can make 2 bonds. So we would have an O. And I've put the 2 unpaired electrons on either side, but it doesn't matter if you chose to put one on the top and one on the side, that would also be fine. Okay, and we could then put our chlorine here. And we could replace those bonding electrons with lines. And there we are. Could you grab your molecular geometry sheet? Where did I put it? Oh no, I haven't got it. I'll have to print it out. That's irritating. No? Molecular geometry. Where are you? Molecular shapes? Is that it? No. Oh, for goodness sake. I'm done with that then. Oh. That's what I did. There we go. Not that one. Okay. Okay. So we had O, Cl, Cl, and remember, these lone pairs, although they don't look like much in this Lewis dot structure, you could draw them like this, yes? How many electron domains are there around the oxygen atom? Is a bond a place where electrons live? Do electrons live in bonds? Yes. So there are electrons living here. There are electrons living here. There are electrons living up in the lone pair there and in the lone pair there. So how many places do electrons live? 4 places. So that means that we are looking at 4 electron domains, and that means our electron geometry, okay, this is the electron geometry, is tetrahedral. And that also means that the hybridization is sp3. Oh, I should write hybridization. Yeah. And if you haven't had the little lesson on how to count that, you just go around and you say SPPP, which gives you sp3. Does it matter which one is the S and which one is the P? No, because those aren't really S electrons, those aren't really P electrons. They have nothing to do with that. It's just a quick way to find the hybridization. We'll do hybridization after Christmas, okay? Other than just recognizing it. So over here, just so we're clear, I could call this the S and these the P, 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 or I could call this one the S and these the P, P, P. I'm just counting to get the designation SP3. Yes?
Is the SP3 from the SPDF?
Yes. But those electrons are not in s orbitals and p orbitals because they get hybridized into 4 sp3 orbitals. But we're going to do that later. So just be okay with counting them up and saying, what's the hybridization? sp3. Okay? So before Christmas, that's all you're going to get from me. Okay? Yeah, I'll explain after Christmas. Yeah. Okay. So we have one where we have 2 lone pairs. Yes? So if we look at our structure, 2 lone pairs here and here. So although the electron geometry is tetrahedral, what is the molecular geometry? The molecular geometry is bent. Is good? Okay. Okay, so that's our OCl2. Now, what if I asked you to make a, yes, sorry.
Can you explain why it is bent?
Why it is bent? Okay, good question. So if we look here at our tetrahedral shape, let's find a tetrahedron. Tetrahedral. Okay, this is tetrahedral, and because it has bonds on all 4 electron domains, because it's got an atom at the end of each of them, we call it tetrahedral. Because if you were to make a plane here, so if you cut out a triangular piece of paper there and put it there, you would be able to put one here and one here and then one on the back. That makes 3 sides, and then the bottom makes a 4th side. Okay, so we have 4 sides, and what do we call a 4-sided figure? A tetrahedron. Okay, so that's why this is tetrahedral. So far, so good? Okay, now let's find a bent one. That looks promising. Yes, okay, there we go. So now, instead of having atoms on the ends of the electron pairs, we just have a lone pair here, non-bonding, and a lone pair here, non-bonding. Yes? So the actual molecular shape, these are like invisible. Yes? Because really electrons are very diffuse and whatever. What shape is that?
That's bent, I guess.
Bent.
Oh.
Yes? Because it's not a straight line, it is bent. Okay? So when we look at molecular geometry, we say if we ignore the lone pairs, what shape do we get? And that shape for this one is bent. Yeah? Okay. So that's the OCl2. I would like you to draw a Cl2 molecule, and I would like you to draw an O2 molecule. And make sure everyone has a complete octet. Hopefully the CLs are fairly straightforward. Yeah? Okay. How are we going to get a complete octet for oxygen? If I was to share just these guys, that would give the oxygen on the left 2, 4, 6, 7 electrons. Not good enough. Besides which, almost never do you find an unpaired electron in a structure, okay? There are exceptions to that, but we're not even going to deal with them until like after Christmas, okay? So we cannot have an unpaired electron, and we cannot have only 7 electrons. How could we fix that? How could we make the oxygen on the left happy?
I guess you pair both of the electrons up.
Yeah, we're going to also share these 2 electrons. Okay, so we're going to share black and red and black and red. And if we replace those dots in the middle with lines, how many lines will we have in the middle? 2. What kind of a bond is that? That is a double bond. Now that is a perfectly good Lewis structure for O2. How could I make it look more geometrically accurate? Sorry, question.
Shouldn't you move the lone or whatever, those paired electrons, like, no, those 2 electrons move to the bottom left and the bottom right?
Yes. Okay. So the question, that was just what we were getting to. This is perfectly good for a Lewis structure. Lewis structures are just 2D representations, and they're all like squared off. You know what I mean? Everything's like top, bottom, left, right. However, should you want to, you could make this more accurate. Electrons want to get as far from each other as possible. So we have electrons here. Where should the electrons go to make them as far from one another as possible? What kind of shape should we make? Yes?
I guess each electron says like 120 degrees.
Yeah, each electron is going to be at 120 degrees. How many degrees in a circle? 360 degrees. So if we split that up into thirds, that's going to be 120 degrees. So I'm going to put my electrons there and there. Now, if I asked you what this molecular shape was, it means you can ignore the lone pairs. And if you ignore the lone pairs, all you have is this. What type of shape is that? Linear. However, what if I was to ask you, let's focus on this oxygen here. Okay, so we have this oxygen, and it's got a double bond there, and it has a lone pair here. Let's see if I can draw the little bubble thing. A lone pair here, and a lone pair here. And as we were saying, this angle right here, what's that angle? 120 degrees. I'm going to put approximately because we'll learn a few things that change those a little bit, but only a little bit. Okay, so that's 120 degrees. What is the electron domain shape here? Look on your, what is the electron domain shape and hybridization of the oxygen? Is it tetrahedral? No. Is it trigonal planar? Yes, because we've got 3 electron domains, 3 areas where electrons live. They live in the double bond, they live in the lone pair, and they live in the other lone pair. Okay, so in this case, we have our oxygen. We have a lone pair, and we have another lone pair, and that is bonded to another oxygen. So what is the hybridization of this thing going to be? sp2. And how do you count that? You go s, p, p. You just count up the electron areas. spp gives you sp2. Now that's lovely. What if I wanted you to make a compound between magnesium and oxygen? Don't forget that magnesium is a metal. So are those guys going to be sharing electrons? No. What's going to happen to magnesium's electron? Where is one of them going to go? It's going to go and slot into that little hole there. And this one's going to go and slot into that little hole there. So we will end up with Mg and it has a what charge? 2 plus. And then we have our O, which has its original 1, 2, 3, 4, 5, 6 electrons plus the 2 extra from magnesium, making it a complete octet. 2 minus. So we use brackets and a 2 minus around that. Is good? Could you do MgCl, like magnesium and chlorine? Well, that's nice. Magnesium, one of its electrons can go here. Yay. What's our problem, though? We need another. What do we need another of? Chlorine. right? Because otherwise we don't have enough places for those electrons to go. This one can slot in here, and we will end up with Mg, which is 2 plus. It's lost its 2 electrons, and we will also have 2 Cl. Now it has a complete octet minus. Is good? Okay, and that's why we have MgCl2. I don't think you're going to get called on to draw Lewis structures for ionic compounds. It's not very common. Usually it's going to be for covalent compounds or covalently bonded elements. Yes? And that's why we have, if you look at this thing, it says how to draw Lewis structures of covalent compounds 8-step method. Because not all substances are going to be as beautifully simple as OCl2 or Cl2 or even O2 is not too bad. We'll get into some pretty complicated ones by the time we're done. Okay, so let's hop back over here. So Lewis structures, always remember that they only show the valence electrons. They only show how they are connected. They do not show the 3D geometry. We have to go and consult our geometry table to figure out what their shape is. And eventually, hopefully by sometime shortly after Christmas, you won't have to consult your geometry table anymore. Okay? When you're drawing Lewis structures, you're always going to follow the octet rule, except we already know one. How many does hydrogen want? Hi. Oh, you're here about the ceiling.
Yeah.
Yeah.
Anything today?
Nothing today. No. Pardon me? No. No.
I'm done. I'll throw them all back once we do.
Fingers crossed.
Yeah.
Yeah. Okay.
It's good for now.
Yeah.
How about what about the popping prepared?
Yeah.
One
Yeah.
Then I'll do a prompt.
Okay. Awesome. Thank you.
All right, have a good one.
We already know hydrogen does not want 8. How many does it want? 2. And that one makes sense, right? Because 2 electrons, that fills that 1 and n equals 1 shell. But now we have a few little weird ones. Beryllium, well, first of all, beryllium is kind of a metal. So what is it doing covalent bonding? Well, it does, because it's not a very good metal. If you look at where beryllium is on the periodic table, beryllium is right here, which puts it right next to boron, which is here. And boron is a metalloid. Yes? So that means that beryllium is not a very good metal. So can it bond covalently? Yeah, sure. Okay. Same thing with aluminum. Aluminum is also right beside the staircase. If you remember, our staircase goes down like this. So beryllium is right beside the staircase, even though it doesn't look like it because all the transition metals are in the way. Aluminum is also right beside the staircase. Okay. Whoa, I'm making a mess. Yeah. So hydrogen wants only 2. Beryllium wants only 4. Don't ask me why. I don't know. Okay, beryllium wants 4. It is stable with 4. That's its happy place. Okay? Do you have to memorize that? Yes, you do. Okay? Boron and aluminum want only 6. Okay, so boron and aluminum want only 6. Why? Again, I don't really know. They're stable that way. So if we go take a look at the back of this sheet, okay, where it says patterns in Lewis structures, we have the octet rule. Most atoms want a full octet. Yes, 8 electrons, full valence shell, life is good. We know that hydrogen is happy with 2. We know that beryllium is happy with 4, and boron and aluminum are happy with 6. How can you remember this? Look what we have. A b-ball, basketball, b-ball. And look what they spell. B-ball. Okay? B-ball. Is good? Helpful? Okay. And I'm not very good at like sports, so I actually don't know how many people are on the basketball court at any one time, but I know that there are less than 8. Am I correct? Is that correct? Okay. There you go. So there's less than 8. Maybe that will help you. You remember I said we're never going to have like an unpaired electron. Nitrogen is an exception to that, but only if absolutely necessary. We won't even look at those until after Christmas, so you can just ignore that for now. And finally, in row 3 and below, you can throw in some extra electrons. And it's because what happens as you go down the periodic table? The atoms get bigger and bigger and bigger. So there's just sort of more room out here to accommodate extra electrons. So you can just kind of jam them in. Okay? But you cannot do that in neon or helium. Yes? Yes. And they used to think that they were hybridizing d orbitals in there as well. So after SPPP, so you would have the S and the P and the P and the P, it would be SP3D and then SP3D2. But apparently that's incorrect, so we don't teach it anymore. Okay? But yeah, down here from row 3 and below, you can have 10 or 12 electrons, and that's okay. That doesn't mean they have to have 10 or 12. It just means that they can if it's necessary. If you're like, oh, phooey, I've got an S and I've got 6 fluorines. And remember, fluorine is a halogen, so it's only got 1 unpaired electron. It can only form 1 bond. So who do all of those fluorines have to stick to? If I've got a sulfur, every single fluorine has to stick to the sulfur. Yeah? So if you've got no choice, throw those extra electrons on phosphorus, sulfur, chlorine, any of these guys in here, okay? These guys can hold 10 or 12 electrons and it's okay. All right, back to here. There we go. Yes?
You have to remember all of that.
Yes. But it's not actually that bad. Right? You'll go along and you'll be like, oh, this one needs to have more electrons on the central atom. Okay? It'll be okay. We'll come to these rules as we go through. So in this particular 11.1a, the only one that you have to deal with that's not normal is the incomplete octets. That's what they call them. Incomplete octets, the b-ball. Okay, so remember that how many does beryllium want? 4. How many does boron want? 6. And aluminum wants 6. And I'm just going to keep repeating that over and over again until it starts to stick in your head, okay? All right, so back to where we left off. Before we start drawing Lewis structures, remember these 6 things. Hydrogen and fluorine form only 1 bond. This is like always. They will always be on the outside, and they will never double bond. So hydrogen and fluorine They're always on the outside, and they never double bond. Yes.
Why can't Cl, Br, I, or At double bond?
Mostly the Cl. Why can't Cl double bond? Because most of the time, Cl has 1, 2, 3, 4, 5, 6, 7 electrons. It's only got room for sharing 1 because it's already full. But do you remember what I said about row 3 and below? Row 3 and below, because they are big, they can accommodate more than 8 electrons. So instead of just having this 2, 4, 6, 8, you can have like 10, 12 sort of on the sides. Okay. Do you remember those octahedral structures you looked at? The molecular shapes? Octahedral, and then the one with the axis and the equator with 1, 2, 3, 4, 5. Those ones are those expanded octets where you have more than 8 electrons. Yes? In terms of orbitals, they are in, they're in molecular orbitals. And to be honest with you, anytime you have things bonded, they're no longer in atomic orbitals, they're now in molecular orbitals. Okay, we'll get there. We're just doing the Lewis structures for now and looking a little bit at the shapes, but we'll get to the rest of it. So usually chlorine, bromine, and iodine only form 1 bond, and usually they're on the outside. So this is a usually. So we have some exceptions here. You can see we've got ClO2, IF5, BRF3. What are you going to do? Fluorine only ever forms 1 bond. So you would have to stick the I in the middle, and you would have to go 1, 2, 3, 4, 5, and have your fluorines on there. And that would give that iodine how many electrons around it? 2, 4, 6, 8, 10. You were okay when they were little models. Let's look at one of those. Where are you? No, I need one that doesn't have lone pairs on it. Oh, there we go. I, F, 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 F. Yeah? Trigonal, bipyramidal. But we're not there yet. That's 11.1C. No, D. No, E. So we're on A. So just relax. Okay? We're not doing these ones today. Also, the central atom is the least electronegative. Usually, and if there is carbon, carbon will be central. Why will carbon always be central? Because it can form 4 bonds. Yep, so it's good to put in the middle. All right? Other tips, if carbon is not present, generally the singleton atom will go in the middle. So if you're like, I don't remember which one's more electronegative or least electronegative, but if you look at this, who would go in the center here? The I. Who would go in the center here? The Cl. And its Cl is less electronegative than oxygen. Who would go in the center here? Br would go in the center, and bromine is less electronegative than fluorine. ICl4, I is further down the periodic table. Things further down, are they more or less electronegative? Less. So I would go in the middle, both because it is the singleton and because it is further down on the periodic table. Okay? Yes?
We have to memorize it like exceptional cases where it is not middle.
No. No. Okay, so NH3, if we have NH3, who's going to go in the middle? N. And N has, it's in group 5, so it has 1, 2, 3, 4, 5 electrons. How are the H's going to arrange themselves? Hydrogen each has 1 electron. There's going to be 1 here, 1 here. These guys are going to share, and 1 here. Yes? So we would have N, H, 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 and a lone pair. What hybridization is the N? Count the places where electrons live. Where do electrons live? They live in bonds. 1, 2, 3. And where else do they live? Lone pairs. So how many electron domains do we have? 4. SPPP gives us SP3. Feel free to check out your molecular geometry chart and tell me what is the shape of that. Trigonal pyramidal, yes, because we got a lone pair. And let me see if I can find one of these guys here. Here we go. Do you see how it's based on a tetrahedral shape? 1, 2, 3, 4 sides. That would be our electron domain geometry. But remember, when we're doing our molecular geometry, we ignore the lone pair. Yeah? And here, if you put a side on each of these, do you see how you have a little pyramid? And how many sides to the pyramid?
4.
How many? Oh, how many, not sides, I mean, what is the base of the pyramid?
3.
It's a triangle. So this is trigonal, and it forms a pyramid, so it's trigonal pyramidal. Okay, good stuff. Do not put more than 4 pairs of electrons around an atom unless it is in period. Three or lower. Electrons must always be in pairs. Oopsie, this was supposed to be up here. It wandered away. Or in bonding pairs. Like I said, there's a few exceptions, but we're going to ignore them. And when in doubt, think symmetry. When in doubt, make it symmetrical. Yes? Unless I tell you otherwise. We've already read through patterns in Lewis structures. Actually, we haven't really. So if you want to go to 11.0b, that's page, let's go to page 4. I didn't print this out as a separate handout because it's several pages long, but you can see hydrogen only ever forms how many bonds? 1, and you can see that's because it's got 1 electron, yes? These are our incomplete octets, so you can refer to this while you're learning these, okay? And then we have beryllium, which only ever has 2 bonds, beryllium, no lone pairs, no double bonds. Boron and aluminum, only ever 3 bonds. Okay. Halogens. We've only got the one unpaired electron, so they only usually make one bond. You can see here on the side, we have some of our row 3 and below. If we've got I in the center, or bromine, or chlorine, those are all in row 3 and below, and you can have up to 6 pairs of electrons, 12 electrons or 5 electrons, okay? And you can see we have here with the chlorine 2, 4, 6, 8, 10 electrons, yeah? And does chlorine double bond? No, but occasionally it does. Right? Does fluorine ever double bond? No. And I'm going to keep harping on that because so many people, even though I keep harping on it, double bond fluorine when it comes to like a test or a quiz or whatever. Yes? Beryllium, I don't know. I've never seen it. It's usually bonding with fluorine or hydrogen, so maybe that's why. Okay. Carbon almost always has 4 bonds. We do have some exceptions. You can see over here, how many bonds does this carbon have? It's got only 3 bonds and a lone pair. And same thing over here, 3 bonds and a lone pair. But all the rest of the time, you can see this carbon here has 1, 2, 3, 4 bonds. How many electron domains does that carbon have, the one in red? It's got electrons on the left, and it has electrons on the right. A triple bond is 1 electron domain, okay? So if I said, what is the hybridization of that carbon? sp. sp. Yeah? Be careful though about like drawing these S's and P's on there, like say on an exam, because that is not an S bond and that's not a P bond. There's no such thing, okay? How about this carbon here? Let's call this the blue carbon. I'll make it blue. What's the hybridization of that carbon? sp3, spp. What's its shape? Feel free to look it up. It's fine. It is tetrahedral. Okay. SPPP, tetrahedral. What shape is the triple bonded carbon? What shape is this? Linear. SP is linear. So if something is SP hybridized, it is linear. So this guy here is sp3, tetrahedral. This guy here is sp, linear. And what do we have in this structure here? How many electron domains? We got 3 electron domains around this carbon and around all of the other carbons. Can you see the bond angle there? That means the angle between the bonds. What is that angle right there? 120 degrees. Okay, and this carbon here is, what is the hybridization? sp2, and the shape is trigonal planar. Let's see if I have one of those kicking around here. Oh yeah, okay. So here we have single bond, double bond. So we have one electron domain, two electron domains. A double bond is one electron domain. And you can see that we get a 120 degrees and a 120 degrees. Okay, trigonal planar. Trigonal planar. It's in one plane. How about this carbon here? What is the hybridization and shape of this carbon? sp2. And the shape is trigonal planar. Yes. And while we're at it, we'll learn some bond angles because you already know the 120, right? And this one's really easy. What's that bond angle? 180. And I'm going to tell you the tetrahedral bond angle. You're going to forget it, but I'll tell you it many, 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 many times. You'll write it down many, 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 many times. This is 109.5. Okay? Sounds like a radio station, doesn't it? 109.5. I can't draw. That's terrible. Sorry. Okay, so we had hydrogen, beryllium, boron, aluminum. Those are incomplete octets. Halogens usually only form one bond. Fluorine only ever forms one bond. Carbon usually forms 4 bonds. Occasionally, it can do something different. Oxygen. How many bonds would you expect oxygen to always make? Usually 2 bonds, but as we saw up here, sometimes we can get 3. And if we have ions in particular, we'll often get like a 3 or a 3. And we'll sometimes get, will we ever get 1? No, we'll sometimes get 3. Or 1. Look, there's a 1. Okay? There's a 1. Don't worry, oxygen just does all kinds of stuff. But it'll become more obvious as we do more practice. Nitrogen. How many bonds would you expect nitrogen to have? 3 bonds. And look at that. When you have diatomic nitrogen, it is a triple bond. What is the hybridization of that N? sp. What is the hybridization of this N? Well, we got 3 bonds, S, P, P, and what else do we have? A lone pair, so that's S, P, 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 that is sp3. How about this nitrogen? sp3. How about this nitrogen here? sp2. And you see that 120 degree shape? Yeah. And one thing I want you to notice is when we have ions, what do we put around them? Brackets, square brackets, and a charge. Is good? Okay. Here's a nitrogen that has an odd number of electrons. That makes me sad, but there we are. Okay. Question based on some periodic properties. When does class end today? Like 3 minutes? 3 minutes. Based on a periodic trend that we have learned about, or sort of any periodic trend, why do you think I've put that lone electron on nitrogen instead of on oxygen? Why is that a better structure than Oxygen is better at doing what? Pulling electrons towards itself. So this is not an impossible structure, but it is a less likely structure. Okay? And I think that's it for today. You guys have review to do over the weekend. Nothing on this is assigned over the weekend. All right, we're just sort of getting a little preview. I forgot to do the demo today, so we'll do that next week.
Let's do composition. Review. And if anyone is interested in oxidation reduction, there's going to take place in my later here. Kind of cool. Like oxidation is using game and it's saying everybody that's I have positive ions. And this is but it's just right. You know, kind of this like sort of reddish kind of stuff. No, it's actually like neutral, like so it's problematic. So the new plus is your average electrons and turning it to proper zero. Oh, that is blue and there's actually this one skipping away. That's obviously how it so most of us can have two different studies. Yeah. But this one is really cool. So this one, we got on my phosphate, sulfate. Okay, this is actually from lab. Yeah, speeded up the. Zero. Yeah. So the sulfate is a spectator ion, and the aluminum is having a tail. Oh, good. She said that 80%. No, the other one I got up to 10 fluid method. Yeah. I know. Everything else is correct.
Excuse this interruption. This message is for staff. We're about to start the Healthy Schools meeting in Mr. Culbert's room in the next few minutes. Thank you.
Was that blue water bottle from your fourth grade class? Because
Yes.
I might have left it there. I probably would.
Is it yours?
I think so.
Well, then take it.
I'm not skipping. What's the hall? What is the hall? You get up from yeah, I froze them.
So did you say this? Said I feel like cookies should be involved.
I don't know yet, I don't know why.
I don't know why.
Yeah, I was really bored. So I picked something from the question and I feel like a baby. I felt like totally unrelated. Hey, the fake out, don't pop. Why is it there? Oh my God, don't say. See, I almost thought, you know, we had a different set of. I know. That's like. But evidence, like you keep it, you cherish it.
Every single day.
Still not leave back. You don't gotta do this. You're vibing.
And
You can pass it on.
very good.
Hi.
I'll resend you the link. tonight.
Perfect.
And then for the paragraph, I'm gonna send it to you during
Okay.
the weekend, and then
Cool,
you
cool.
can probably just paste it in.
Okay.
You'll be able to check it because it's due like at 1 p.m. on Monday.
Okay.
So worst comes to worst, I'll just be like submit it like during lunch or something.
Gotcha.
Thank you.
Everyone read the library. Carry that. Infinitely splashing with my.
Yeah.
All right,
Shut up.
Everyone read it. No one read it. Everyone was like.
Yeah.
Actually, I think I did, but I got like
Jurassic Park.
Move in, relax.
They call me Ed.
Move in.
They call me Ed.
You're like, that's so much shit. He told you that.
Thank God no one was
Well, I mean, like, he's.
homework is over too much.
Wait, you're pregnant?
I need to TV. Why not the camera?
Okay, I wonder if you want that. Give me premium. I'll show you. Some shit we had to do. Very unnecessary ones. I'm having these things almost. No,
It was three. It was three more.
Oh, I don't know. I was carrying this. If I don't mind, why do you say I do not? I love what? You don't have good knowledge.
You wanna go all night? Yes.
I need a.
And also, we can operate with
No, but like, show the work.
But I will,
Because everyone got it. Everyone.
Monday.
So I thought.
I'm gonna study, I'm gonna study.
Pity
All
shot.
the years. I'm gonna graduate.
I learned this much. Even the beat test starts. Loki,
Oh, I can't sacrifice that.
please. Wait, you're.
Like, how would you help
Will
me?
be, no, I'm not.
I don't know, like, I can see, I'm like,
Why would you do it? I did it from his driving side and it did not work.
don't do that.
I don't know, it's because he doesn't give the actual. He expects us to understand. But you know, if I put things on that one. Like that one, like I don't want to make like 30 million accounts. You have any one.
Oh, I haven't figured out.
It's so hard to do every time.
Okay.
I don't want your time.
Oh,
I need you.
Yeah, like, you know, white head there. And then I'm gonna wear my one that shows maybe no questions, and then I'm gonna get that. Yeah, I'm done. And then, I don't know if do it, because I want to like update about it. So my brother told me that I like really bad at it. So I can. My brother said really bad at it. I'm like, I'll do that. Also, like back to my mom. Like, I'm like, you can have your. It's just sad. I actually really that bad. Yeah, I don't know how. I don't know how. See. I just because
All of that.
I can hear you.
No,
I can do that. I can do that.
Hey, y'all in a nice break.
Not that.
Hey, we're giving you 90 years.
Mister, I can get an 85.
How old do you look at? Or you don't work anymore?
Oh, get there, bro.
So is the basement like very strict? Oh, you're. You and your.
You didn't come to six.
Shit. Oh, no,
Watch me do all this and he doesn't even take it. I like this chart. I don't think you can do very well.
Oh, this is it. Can you fix it, Dario? Who makes it? Where's the movie?
Well, I'm not gonna lie.
You fix it? Do something. I'm not letting you take it home.
I am. I'll let you do
No, fuck, it's mine.
Now you're getting fixed.
Bro, I'm literally never gonna give you anything. I'm not giving you, when you get charged, you're gonna die, it's gonna die, bro. No more flash time for you. Okay, alright, you do that. He broke it and he wants to keep it even though he can't fix it. He knows he can't fix it.
Let me see.
Don't worry about that.
You lost it now, so you have to buy it.
Bro, you owe me money, you idiot.
But I'll
You literally used it all bad. But like, no, you fucking broke it. Fucking down.
How is it broken? Yo, it's just unfixable. Yeah, it's not. It doesn't see how this happens right there.
Do you want to go?
Collective after breaking it. So you got Dario, Sam.
No! Why would you let him drive?
It's collective.
We are
Oh shit!
Bro, you're
Yo, you talk about way better. What it
You're a fucking idiot.
Oh, that's how it works. It's not
I'm not always part of that. Everything else is fun. I'm fighting on my
You're not even Canadian. Are you Canadian?
I'm right. Yeah.
Are you looking at?
Oh.
Are you looking
All right. Well, I want to be. Wait, what's the other? Other not being with spirit thing? What's the other spiritual thing? Oh my God! What about? No, yeah. Everybody has to be like that. I'm not letting go. Have you? It's got all these 3 2 minutes. Oh, I'm never getting an office. I didn't say what. I
So now, and that's, you know, but that's not the best thing. He had on stuff.
Why don't you just do the questions? Where was online?
So, how is that better?
Then again, how do you know this? That's what we got. He's not sorry. He thinks it's not his fault. It's what? Yeah, he said you broke. That's good for me.
That's the stuff that we're like,
Is so much.
Yo, it's actually hard, but that was the hardest. That was the hardest. It's so light. Yeah, I know.
Yo, why do you have something? Yo, why are you like this? My Yo, put on speaker.
Where are you at?
I didn't see her.
You're paying. You're paying.
I like some keyboard backwards.
Yeah, you.
What does it say? I'm not actually. I didn't stop because you didn't
Bro, he's honestly that's the first step.
It's like this, like y'all know about that. This is everything here. Yeah, I remember exactly. About a pass your ass. About a pass. I'm asking you to take I've been legends logging every 4 hours. I relate to this. I don't want to get back. That'd be so hard.
I would hurt this, bro.
It's
fucking broken. Oh, you can do it, bro.
Swap it up. It's already broken.
Why don't you bring it home broken, ready to temper? You're not a mechanic, but you're not gonna break apart the things.
What are you planning to do right now?
Hey man, come here.
It's the core that's the problem, you idiot. It's not the inside of it. It's literally
He's gonna open it.
No, you're not opening it up.
This guy? It's like the film.
Or at least it's nice when people like to.
Yeah, I trust it. The bag is gonna explode on. It's like, it's not a lot of. You know what I'm talking about? I'm pretty glad.
Y'all let me suck each other off like that. And you should know.
What do you do? What do you do?
No, we're not. I can't lock you.
Don't know, yes, I
Maybe you're not ready because you know we're all starting.
Yeah, I know.
Yeah, for everyone. I'm honestly going out. As you said. Unlike go there. Well, $2.
Why are you asking me that? Can you ask that yourself?
Why are you taking a picture of Darren? It's gotta No matter how dumb they're gonna keep
Right now,
Why?
He is so goddamn annoying. Well, he's like telling everybody what I do wrong, telling everyone how I only
Yeah.
did.
Get on, man.
Why is
Why did you?
It's not $50.
there you go. Z.
Oh,
This is not real.
she's not good.
They have
Yeah, this is not too soon. But if you know this, but the good thing is.
Bro, we got all your 8 hours.
Hey, yo! Yo!
Yeah, but I said three.
Yeah. Doesn't stop on the.
What does that mean to do with him? You
He's
still
so
hold me.
annoying and he's lazy.
Cases is blaming you.
He's like lazy to stop.
You put it on your mom's life. You can't do anything about
It's broken.
I'm just gonna fix it. 1 second. I'm probably just on fucking back end.
Oh, I think it's a collective.
What if I think it's AI?
I'm not fixing it there.
So you can't, I just want to like, it's not gonna replace where you said,
Five black guys. Like, I know, work like this, so what the hell? No, I think Jerry should pay the one time. Where's my super? Yeah. I literally want to see You're taking off your.
I emailed them not to be able to.
I have this with my son.
Greg, last time.
I'll watch it again.
I would go all up to like.
You eat other of those? Go like right now. It's up. You're the one here.
Is there any comments? No way.
Oh my God.
What is this?
Life's the worst thing. Are you forcing out any violence? Like 30 Yeah.
I'm going. You put on your mom's life. It's already up.
You haven't even let me try.
You're not gonna suck my shit open.
Let him try.
Well, that's what you Well, this is trash.
Do it, bro.
I would do it better.
Bro, that's just gonna be hard for you.
Yeah, one more.
No, why am I this?
Guys.
I did two.
He guessed what I guess my it points a lot. Gio gets that.
I didn't give it to me.
This is what we don't. So you're fine.
I'm gonna get this again. How am I getting more sixes? Not good.
That's not wrong.
No, my dad told me to come home right after that.
I used to don't give a fuck. I can cancel that. I can't wait. Just come, trust. You're gonna be happy.
Any extra books? Mine completely fell apart.
Hold on. Do you have your book? May I see it?
Yeah.
No, I skipped lunch. I don't have. Why?
I remember I would text you.
Those two are these.
Walmart that in there. I have to. I don't get to watch. Like, be an issue. This one. I don't tell you I probably. Oh my god. Look, hey, I want to which one ACC. Where are they? Okay. Let's see. Look at her.
I still.
Oh, I'm fixed. I'm fixed.
I was get out of the.
Okay. Where are all my students?
I don't know.
I know I've got.
Oh, thank you. Oh, Peter. Matinee.
Oh.
Yeah.
I need blue.
The back. Hey, you can. He gave me. All of the. Really.
Oh, yeah.
This is all I work.
No worries. The homework was 61.
Yeah.
Oh,
Okay, today. Oh my God.